Hello, hello, hello. We are going to talk about volume. And no, I'm not talking about the volume on your TV or on your computer. I'm talking about volume as in space, taken up by a 3D shape. So we've actually talked about, we're actually partway through this unit, partway through this lesson, talking about comparing volume of cylinders and spheres and cones, the things that have circles in them, and how that compares also to what we've already learned about prisms. So we're going to continue doing that, specifically today comparing volume of cones and cylinders. So we are on section 26.2. It's in your notes book on page 230. 230. 230. All right, let's start at the top here. It says, you can compare volumes of cylinders and cones. Use the pictures below to help answer 2 through 7. So that's this first page. Take a look. We have a cylinder on the left here, which has a radius of 4 for the cylinder, for the base circle. It's also got a height of 3 altogether there. We've also got a cone with the same circle on the base, and it's a height of 3 as well. So number 2 says, how is the base of the cylinder related to the base of the cone? Well, if you look at them, they're the same. The exact same circle with the same radius. So we're going to write that down. Same circle. We'll say same circle base. With same radius. Now, number 3 says, how are the heights of the cylinder and cone related? Well, the height of this one was 3, and the height of the cone is also 3, so they both have the same heights. And those heights are the 3 feet. So far, these two things are very similar, but they're still different shapes. So number 4 says, find the volume of the cylinder. Now, I want to remind you that to find volume of cylinder and shapes in general is big B times H, where big B is area of the base. And in this case, the base is a circle, so in this one, it's pi r squared. So if I'm going to find the volume for number 4 of the cylinder, and I would take pi r squared, so pi times the radius squared, so pi times 4 squared, and then multiply it by the height of the whole thing. That should be an h right there, if you couldn't tell. So times 3. It says leave your answer in terms of pi, and I'll show you exactly what that means. But one thing typically you're going to do is multiply these all together on a calculator. The only thing I don't want you to do, or the only thing I want you to multiply together though, is the numbers, not the pi part. We're going to leave the pi in there. It's another way to write answers with pi in there, is just leaving pi as pi. So let's multiply 3 by 4 squared. 4 squared is 16. So 16 times 3, you can check your calculator, is 48. So it'd be 48 times pi. And we're going to leave it like that. When it says leave in your answer in terms of pi, that means leave pi in your answer. Okay? It's hard to tell exactly what the number is because it has pi in there, and that's like 3.14 and so on. But we're going to leave it that way for today, for this one at least. And that would be feet cubed. Okay? Now number 5 says find the volume of the cone. Now if you recall in our lesson yet last time, the volume of a cone is super similar to a cylinder because if you look, they're almost the same shape. But the one difference was we said it was 1/3 area of the base times the height. In other words, a cone takes up 1/3 of the size or space of a cylinder. So we're going to do everything the same though. It's 1/3 pi r squared times the height. So for this one, we would do exactly the same thing. We would just have 1/3 in there times pi times 4 squared times the height of 3, which is essentially taking 1/3 of 48, because we're just multiplying the numbers together. We're going to leave pi in there. And 1/3 of 48, or 1/3 times 48, or 48 divided by 3, gets you 16. So my answer would be 16 pi feet cubed. So Number 6, now looking at those things, it says, how does the volume of the cylinder compare to the volume of the cone? Well, the cylinder is bigger, and it's just 3 times bigger. And one thing that I like to do in class would be to take a cone and take a cylinder that's the same height and the same circle base, and actually take water and see if it fills up 3 of them. And it does, which is, it just shows that a cylinder is 3 times the size of a cone that has the same height and radius. So number 7, well, here we go. Number 7, suppose you fill the cone with water and empty the water into a cylinder. How many times will you empty the water from the cone into the cylinder? Explain. And that would be exactly the same thing, 3 times. And to explain that, it's because a cone is 1/3 the size of a cylinder. And we're assuming those cones and cylinders have the same height and radius. So you can fill 3 cones into that cylinder. Let's turn the page. Number 8, the top of page 231, it says the formula for the volume of a cylinder, which we said is big B times h, or pi r squared times height. The formula can also be written right there. What does the B stand for? The big B, capital B. Well, what did we say before? What have we been talking about? Capital B, it represents the area of the base. In this case, we'll say pi r squared. I'll write that one out, because it's a circle. So in this case, it's pi r squared. Number 9, complete the equation using the following, using your answers to the problems 5 and 6 on the previous page. So, whoa, did not mean to do that. Sorry about that. One second here. Okay, should be working. Sorry, number 9, technical difficulties there. Complete the equation below using your answers to problems 5 and 6 on the previous page. So the volume of the cone times what equals the volume of the cylinder? So we said you took the volume of the cone, in the case of the thing before, it was 16 pi. What would you have to multiply that by to get to 48 pi? Well, everything we've been talking about, it's 1/3 the size, so if you multiply by 3, it should get you to the volume of the cylinder. So in number 10, explain how you can use the equation in problem 9 to write a formula for the volume of any cone using big B to represent the area of the base of the cone. Well, since we said volume of a cylinder, cylinder volume equals big B times h, and that would mean that cone volume is 1/3 big B times h. Okay, again, a review there. We're just showing that in general it's going to be 1/3 the size. So number 11, compare the formulas for volume of spheres and cylinders. Why do you find r cubed to find the volume of a sphere when you can only use r squared to find the volume of a cylinder? Now this one's a tough question. So I'll kind of explain this one. For a cylinder, after you find r squared, you multiply your answer by the height to find the volume of a cylinder. For a sphere, though, the height of the sphere is half of the radius. So when you multiply by r squared by r, again, you get r cubed. Okay, now that was a really wordy answer, but that's where you get the r cubed from. And then you multiply it by the height, which, well, that the height is the essentially the radius. So it's kind of a lot to explain, but for the sphere, remember it's 4/3 pi times radius cubed. And I think it's drawn out best in our last lesson where we talked about, I think I might have it on here still. Back one more. It's right here. It is explained really well on this page, on page 229, where you're trying to explain that it's actually 2/3 of it, but then that's only half of a sphere is 2/3 of a cylinder, and then if you double it, then it becomes 4/3, and that r squared comes or cubed because the height is actually the radius as well. So that's, we got the radius, but then the height is also the radius because the radius of a cylinder goes all, or a sphere goes all the way around. So we're not going to dwell on that one too much. But I want to finish by having you answer this last question. Try it another way. It says, if the radius of a cylinder is doubled, how will the volume be doubled? Explain. So I would like you to use an example and see if it actually is doubled or not. Write down your response and be prepared to answer that question another time. Okay? But try it. Try it with an example of a cylinder. If you double the radius, will that double the volume, or does it change it in a different way? All right? That is it for today on using volume formulas for cones and cylinders. And we're going to finish this lesson next time, 26.3, of all our overarching goal for this lesson, which is to understand formulas for volume, specifically of cylinders, cones, and spheres. We'll see you next time.